Solving practice trig problems. In the first problem, I want to find the sine of 13 pi over 6. So I draw my xy axes. If I want, I can convert 13 pi over 6 radians to degrees by multiplying by 180 over pi. The pi's cancel, 6 goes into 180 30 times, and 30 times 13 is 390 degrees. So I go from the positive x-axis around 360, 30 more, and I draw my triangle. My triangle becomes a 30, 60, 90 when I drop the perpendicular to the x-axis. The hypotenuse is 1, opposite 30 is 1/2, opposite 60 is square root of 3 over 2. With this triangle, I can now find the sine of 13 pi over 6. It would be the opposite side over the hypotenuse. The opposite side is 1/2, and the hypotenuse is 1, so I get 1/2. In question 2, I want to express the cosine of 4 theta in terms of sines and cosines. It would be helpful to know the double angle formulas. So sine of 2 theta is 2 sine theta cosine theta, and the cosine of 2 theta is cosine squared theta minus sine squared theta. I can then use an angle addition formula and take the cosine of 4 theta and change that into the cosine of 2 theta plus 2 theta. At this point, I can use my angle addition formulas for cosine. So, the cosine of 2 theta plus 2 theta is equal to cosine 2 theta times cosine 2 theta minus sine 2 theta times sine 2 theta. I can replace the cosine 2 theta with cosine squared theta minus sine squared theta. I can replace the second cosine 2 theta with, again, cosine squared theta minus sine squared theta minus, and now I can replace the sine of 2 theta with 2 sine theta cosine theta, and I can replace the other sine 2 theta with 2 sine theta cosine theta. At this point I can stop, but I can also multiply and combine like terms. So if I FOIL the first group of parentheses, I get cosine to the 4th of theta minus 2 sine squared theta cosine squared theta minus sine to the 4th of theta. And if I multiply the 2 sine theta cosine thetas together, I get negative 4 sine squared theta cosine squared theta. I combine the sine squared thetas and cosine squared thetas and get my final answer of cosine to the 4th theta minus 6 sine squared theta cosine theta plus sine to the 4th theta. In question 3, I want to find the 6 trig functions when the angle is 5 pi over 6. Again, I draw my xy axis. I can convert 5 pi over 6 to 150 degrees. Find it in the second quadrant, draw my triangle. That leaves 30 degrees in my angle. I drop the perpendicular, and I again have a 30, 60, 90 triangle with a hypotenuse of 1, opposite side 1/2, adjacent side square root of 3 over 2, but again it's negative in the second quadrant. So the sine of 5 pi over 6 is the opposite side over the hypotenuse 1/2. Cosine of 5 pi over 6 is the adjacent side, negative square root of 3 over 2. The tangent of 5 pi over 6 is sine over cosine, or 1/2 over negative square root of 3 over 2, which simplifies down to negative 1 over the square root of 3.